The final part of our workshop, so you had this. If you actually came to the workshop, we had you actually make one of these. It's a coil of wire. So usually we just wind it around our finger a lot of times. This is about, I think, 20 or 30 turns of the wire. And this is an inductor. So Sid, do you want to explain what an inductor is?
Yeah, so all this is, as you might have learned in physics class, if current flows in a loop, it actually creates a magnetic field. And the direction of that field is according to a right-hand rule. So if you take your right hand and you curl your fingers that are not your thumb in the direction of the current, then the direction of your thumb is the direction of the magnetic field. Yeah, and so that's essentially what the inductor does. It produces a magnetic field coming out of the hole that you loop your wire around.
Yeah. So depending how much voltage we pump through it, the current will change, and that'll also change the magnitude of the magnetic field, right?
Yeah, so the magnetic field actually, the strength of the magnetic field depends on how much current and on how many loops you have in your coil.
Yeah. So since we know what number of loops we have, the actual strength doesn't really matter to us. We just want to be able to change the strength. So just a little explanation of what we're going to do now. Since we can change the strength of the magnetic field or just turn it on and off coming through this inductor, if we put a compass near it or any kind of magnet that can move, that'll actually change the reading on the on a magnetometer, right, which measures magnetic field. And those come in pretty much all phones nowadays. So what we're going to do now, which is really cool, is transmit data from the Arduino to your phone just using this. So let's plug this into 13 right now, and the other end into ground over here. And let's load up the Blink program, just to see what happens. So open up the Blink program and upload it. Okay, it's uploading. So now this is blinking. And here's the thing, when we plug this in, we want to make sure that it's plugged in all the way and that current is going through it. So like this, if you see the LED blinking, that's actually not good. That means this isn't plugged in, because the thing about this coil is that it has very low resistance because it's just a bunch of wire, right? Whereas the LED has some resistance. So here's another thing about circuits is that if you have, the circuit has two paths it can follow, and one path has very little resistance, most electrons will just go through that and won't go through the other one. This is called a short circuit. This is basically like if you just poured a bunch of water on your circuit, you've heard that this causes a short circuit. That just means that there's a lot of paths the electrons can go through that have very low resistance, so they choose to go through those instead of the regular path. So all this really means is that this is a good way to detect whether or not we have this plugged in, because if we do have it plugged in, all the current should flow through here basically, because it's just a wire, there's no resistance, and the LED should be off. So plug it in like this. Oh, just don't touch it.